1 for mod x less than 1, 0 for mod
Uh-huh.
x greater than 1.
Okay, okay. So I have just okay. So we'll solve this, no problem. So fine. So this is again. We'll go to the next example. Find f of x. If f of x is equal to x, mod x is less than a and is equal to 0 if mod x is greater than a, students. Is it clear? So this is what we have at the example. I think you are now perfect how to understand. Yes, which interval we are going to take. Yes, you can see here. So again I'm going to say this interval which it exists. So this is from minus a to x and this is plus a. Is it clear? So now I will take this as, sorry, x axis, and this I will take this as y axis. So what I will do, yes, I will take first mark minus a. So we don't know where the a will lies in this line, so I will just take minus will come in the in this quadrant, so I will take this as minus a and plus a. So both the values are plus, so therefore I will take plus a in this interval. So now I can see this f of x is equal to x means y. F of x is nothing but y. So y is equal to x means what, students? If I substitute x is equal to 1, 2, 3, 4, 5. So it will go x also increases, y also increases 1, 2, 3, 4, 5. Similarly, if I substitute x is equal to minus 1, minus 2, minus 3, minus 4, y also increases minus 1, minus 2, minus 3 means it is a straight line. Sorry, from if x is again 0, y will be also 0, therefore it will touches this line and goes there. So here you can see this is 0. So this f of x is equal to x is a straight line in the interval minus a to a. Is it clear? So means you can see this interval exists, means in this interval minus a to a f of x exists and which is equal to x. What will be the RHS, friends? Can anybody tell me?
Minus infinity to minus a,
Yes, minus infinity to minus a. F of x is
0,
0. Very good. Similarly, here it will be now
a to infinity,
a to infinity.
0.
It is 0. Very good. Okay. So now I think you are perfect. You understood how graphically we can draw. No need of drawing, but for your understanding, I have drawn this. But now we will see. We will not take now all these things now. Again, splitting the values. No, no such things now. Directly we will solve this. See here. So I will take the formula first. Please remember in Fourier, here I have not written, but it is understood that this is Fourier transformation. This is nothing but f of s. F of s is nothing but f. This capital F itself is nothing but, students, Fourier transformation. It is denoted by Fourier transformation. Fourier transformation is denoted by f of s, or it is also denoted by this capital F of this function f of x. Is it clear? So now take the formula first. Always f of s is equal to, so I will not take again f of x. Directly I will take the formula, that is minus infinity to infinity e raised to I s x, right? And this is f of x dx. Is it clear? So this is our formula. Keep in this in mind. Okay. Now I will not take again the intervals. I will show this is 0 and this is 0. It will again take time, right? We don't have time in the exam. So directly only I will choose this interval. Am I right? So I will take interval minus a to a. It is understood. Remaining intervals are 0. This is 0 and this is 0. So if you write direct step, there is no problem. Okay. So now I will take this x. F of x is x. I will take this x e raised to I s x dx. Have you understood, or shall I explain once again? Yes, students. Is it clear?
Yes,
Directly
sir.
have taken. Okay, so no need of again showing this is 0, this is 0, and then you take this, not required. Directly you write down now. Okay, so now you can see, whenever when you take the Fourier transformation formula, don't take integration directly. First you have to modify this always. Then you can see this is u and this is v. Is it clear? Then we can take the integration of u into v, product of two functions, that is Bernoulli's rule we can going to use. So already we have done this in Fourier series also. So this is, I will keep x as it is. Yes, students. This is integration of e raised to isx. So this is e raised to isx divided by coefficient of x. Coefficient of x is I into yes. Okay, minus. I will keep minus as it is. Then differentiate x. Differentiation of x is 1. Okay, then integrate this again once again. Is is constant, so don't integrate this. Only x, e raised to isx is integrated. So you can see this is e raised to isx divided by coefficient of x is is. Okay, already one is there, again divided by this coefficient of x, is divided. So is into is will become I square x square. Is it clear? In the interval minus a to a. So this is how we are going to simplify, students. Is it clear? Now I will simplify this one by one. I will take this first part, I will call this as first part, or one value. Okay, here I will substitute a and minus a in this. Okay, wherever x is there I will substitute a first. So x is a, I will take this a, and this is e raised to I yes a divided by I yes. Is it clear? So a have substituted. Now I will substitute minus a. So minus of minus a. Is it clear? So e raised to minus I yes a divided by yes. Wait, okay. So this is divided by is. So this over first value. First one is over. I will move to the second value. This is my second value. So I will keep minus as it is. I will keep minus as it is. Now I will substitute x is equal to a. So this x is equal to a. I will take this like this. E raised to I yes a divided by I square yes square. Is it clear? Then minus, again I will take x is equal to minus a now. So this is minus I yes a divided by this is I square x square. Is it clear? So I have substituted second value, that is x is equal to a and x is equal to minus a, have substituted. So continue integration, students. You should be now perfect. Yes, open all the brackets. I suggest open all the brackets. So I will just open this bracket. I will get this as a into e raised to I yes a. Yes, what happened with the screen went? My god. Okay, this is 10, nahi? Suddenly screen went. See, no, this is, so you can continue this, students. I don't know where is that. This one. Okay, here it is. Ah, my god, it is there. I don't know. Suddenly the screen disappeared. No problem. So where I was opening the brackets. So I will just take this a into e raised to I yes a divided by I yes yes. Okay. Now minus into minus will become plus a e raised to I minus I yes a divided by I into yes. This minus remains as it is, but please remember here, you know the value. What is I square? Yes, students, please tell me what is I square?
One.
Yes, very good. It is minus 1. So minus 1 is here. I will substitute here minus 1. So now I can see this minus 1 and this minus 1. Okay. I will substitute here minus 1. Minus 1 into minus 1 will become plus e raised to I s a divided by s square, because I square is equal to minus 1. See here students, I have substituted the values. I don't know why this is getting close again and again. I have to finish this example. Siva. Okay. Some problem, I think. This is giving problem that this is not, I think, activated. Whatever it is, this is minus 1. Okay, I will substitute here minus 1. You should be fast. I think more number of this is open or what? Nothing. Okay, so this will become plus e raised to I s a upon s square. Is it clear? Now here you can see in the this is minus 1, minus 1 into minus 1 plus 1, plus into minus will become minus. So therefore I'll take this as minus. Okay, this is e raised to minus I s a divided by s square. So they don't get confused here students. Once again I will tell you, this is very very important. Here you can see there are three minus. One minus is outside the bracket, one minus is here, and another one minus is because of this I square. Am I right? So because of this I square I have taken this minus 1. So don't get confused. So minus into minus is minus. Is it clear? So many of them will make mistake here, so don't do this mistake students. Even practice is not there, even I will make this such mistakes, so you should be careful. So is there any step is missing or anything is wrong, just check once again. Okay, now we see this common parts I will take outside. In this I can take a upon is outside, so you can see this is e raised to I s a plus e raised to minus I s a. Is it clear? Here I can see plus 1 upon s square is common, so I'll take out 1 upon s square. E raised to I s a minus e raised to minus I s a is there. So I will simplify. See, 1 upon I can write like this. 1 upon I will multiply I and divide it by I. So this will be like this. So this is going to become I. Oh my god. Start normal. Okay. So this is I divided by I into I will be I square. So I square is minus 1. So this is I divided by minus 1 or minus I will substitute. This one value I will substitute. 1 upon I is nothing but minus I will substitute. Another value, please remember this, e raised to I s a plus e raised to minus I s a can be written as, can anybody tell me what values I can substitute here students? Yes, it is 2I cos A. Yes, this value I can substitute. Similarly, e raised to I s a minus e raised to minus I s a. I can take this as 2 sin as. Please remember this formula. We know that formulas, these three formulas everywhere, for everything in all the examples of Fourier transformation, we use this formula. Students, is it clear? Okay, now one by one I will simplify. Here you can see this is 1 upon I. I can write this as minus I. So I will take this as minus IA upon yes. Okay, now you can see e raised to I s a plus e raised to minus I s a, can write 2I cos AX. Yes, so I will write this as 2I cos a s plus 1 upon s square I will write here. Okay, e raised to isa minus e raised to isa is minus isa is nothing but 2 sin as. Okay, I will simplify here, 2 sin a s. Okay students, now you can simplify, otherwise you can keep this as your Fourier transform. So we have transformed this, students. Is it clear? So, but you can, if possible, yes, you can simplify. So this will be like this: 2a I into I will become I square. Yes, I square is nothing but again minus 1. So minus 1 into minus 1 will become plus divided by s cos as. So please remember I into I have multiplied. It will become I square, right? I square is nothing but minus 1 into minus 1 become plus 1. So this is 1 upon s square 2 sine a s. Is it clear? So now you can see again what are common things. I will take it outside, that is I will take 2 outside, and I will, if possible, I will take s outside. So s means sorry, s square I will take outside. So I have to multiply here s and divide by s. So this will become s square. So what will remain? Yes, I will take this side. So this will become s a cos a s plus 2. Sorry, 2 is taken outside. Sine a s. If it is required, you can simplify. Otherwise, you can take this as answer. Is it clear, students? Both are correct, no problem. You can take this. Otherwise, after simplification, you can take it like this. This is our answer, students. So both are right, no problem. Is it clear? Any doubt, students? Yes?
So that 2i part is only for that in between plus sign, or for that formula set
Yes.
to,
This
or
one.
both? Yes, sir. We have considered that I for only plus sign in between those and not for
Correct, correct.
minus.
Minus means sign, it will change.
So
So
there
shall
will
I
be
show
no
you
I.
how is this like this? Why it has came like this? I will show you. See,
Sir, can you
E,
explain that last two parts, sir?
these two steps.
Yes, sir.
Okay, see here. I will rewrite. See this. That will be little bit better. Okay. So this part I will write it this side. See, f of s I have taken here. Right. This is equal to I into I will multiply. So it will become I square. Yes. 2a is there. So I will take 2a upon s, and this is cos as it is. Then here I will take plus 2 upon s square as it is sine as. Am I right? So a I square is minus 1 become plus 2a upon s cos as, yes, plus 2 upon s square sine as. I want to take 2 upon s square common. I wanted to take for modification if possible. So what I have done, s and s multiply s divide by s, so that s square I can take it outside. So what will remain here? S and a is constant, so I will take a and s outside. This is going to become cos as plus 2 is outside, s square is outside. So what is remaining? Sine as. So this is our answer. So 2 upon s, 2 upon s square as cos as plus sin as. It is if it is required. Otherwise, you can take this as answer. No problem. Is it clear?
Yes, sir.
Okay. So now we'll go to the again next problem. This is also quite easy. Only we are going to see. Yes, you can take down the next example, students. Example 2, right? So you can write down again f of x. Yes, find the complex Fourier transform of e raised to minus a square x square, right, is greater than 0, hence अरे बाप रे, yes, okay, every 10 minutes it is getting closed. It should be fast now. Okay, hence deduce that e raised to minus, अरे बाप रे, Yes. Hence, deduce that, or I think I've written here, deduce that e raised to minus x square upon 2 is self reciprocal. Is it clear, students? Okay. So start solving, right? How you will simplify? Again, as it is, when you see the Fourier transformation, let it be complex or anything, first you are going to write the formula. So we'll take let f of s is equal to integration minus infinity to infinity e raised to I s x f of x dx. So this formula I'm going to take every time, right, students? Now substitute the values. I will take here, and f of x they have given here e raised to minus a square and x square, x square. Okay. So this is given here, students. Okay, now substitute the values f of yes. So in this example, you can see this is a special example. There is no interval if you just see. Yes. So how you will solve? No problem. Use the formula. So one formula I know that, because this is e, so we know that integration minus infinity to infinity, because there is no interval. So I cannot simplify directly using the integral sign, right? So I will make this formula useful, that is e raised to minus t square dt is equal to root pi. So this is a standard formula, students. So I have to make this function in look like this form. Okay, so this is my destination, I can say. We'll start now. Again, integration. So here, lot of modifications are there, very, very important for the examination point of view. Such type of examples will come, sure, I will tell you, because this is not using directly the integration. We have to modify this such a way that it should look like this, so that our integration will go, only square root pi will come. Let us see. So we'll just substitute the values now. Again, what is f of x? F of x is e raised to minus a square x square dx. So this is equal to, you can see this is a square is there, t square is there. So I have to take this in terms of squares, right? So what I will do here again, integration minus infinity to infinity e raised to, yes, all are in power. Please remember this. See, I will take this now. I s x minus a square x square dx. So I have made it 1e. It was 2e, 1e I have made. And please remember this is minus t square is there. So here also what I can take outside, I will take a is constant. So let us take it outside. So this will be integration minus infinity to infinity e raised to minus a square I will take outside. So that this will become x square. Yes, minus into minus will plus. This will become minus. So minus I yes I yes x, right, upon a square. Is it clear? And this is dx. Alright, students? Yes. Why? Because you can see here clearly. Yes. A square I have taken outside because it is a constant. And this, it will get divided by a square. Now you can see this is a square is there, constant term is there. You can take it outside very easily. But what about this? This is not square. Am I right? What is not square? X square minus I yes x upon a square is not a square. So how I can modify this so that it should look like square of this term? So it is minus sign is there. There is only one formula, that is a minus b the whole square will be a square minus 2ab plus b square. It should look like this now. So a I can choose especially in only for this term. This a is different, this a is different. Okay, for this term a will become x. Am I right? So I will take this as x square only. So look, you look here students, very very important. Yes, simplification you are going to do. If you make mistake, then you will not get the answer. Is it clear? So x square is there, so don't change this minus. Okay, 2 is not there here, so I will just go through that once again. A we have already taken, this is x, right? So b part is there. See, this b part will become automatically is upon a square will become. Am I right? So what is missing here? 2 is missing. A is there, b is there. 2 is missing means I will multiply 2 and I will divide it this by 2. Okay, so now you can see what is b. A I have taken x, so b automatically will become is upon 2a square. Am I right? Okay, so I want, but here plus b square I want. So what I will do? I will add b square and I will minus b square. I will subtract b square. Okay, so b is is upon 2a square. I will square this now. This is I square, s square, 2 square, a square square. What is a square square? 4. A raised to 4. So this I have term I have added means I have to subtract this term also. So therefore minus I square s square upon 2 square a raised to 4. So now you can see this is a minus b the whole square. So what I will do this? I will take this as x minus what is b? Is upon 2 a square square. So this is a minus b the whole square. But remember, this part is remaining, that is minus I square x square upon 2 square a raised to 4. But please remember, I square is minus 1. Am I right? I square is minus 1. So what I can do? Minus into minus. I will just take this minus and I will multiply here. So that this will become plus and I square is removed. Is it clear? Okay. So I will continue here. Sorry. This dx will not come here. It will come down according to the e. So this will be equal to integration minus infinity to infinity. Yes, students, I know all this, what we say, modification. It will take at least 2 to 3 times. It will take practice. Okay, now I'll substitute only this part. Now this part is going to be changed in this form. So this will be e raised to minus a square, right? So everything is in power is going to be changed in this form. So this will be e raised to minus a square, right? So everything is in power c. X minus I, yes, divided by 2 a square, the square plus s square upon 2 square. I will write 4 now. 4 a raised to 4. And this is dx as it is. Okay, students, see here, very, very important modification we have done, and this is very, very important example. So you can see I have still not included the integration. I have kept it as it is. I want to modify this first. So this will be equal to, now you can see it is e raised to minus a square. I will take minus a square in this bracket. So this will be x minus I s upon 2a square square. This is again minus a square s square upon 4 a raised to 4. This is dx. So now you can see this is a constant term, student. So what I will do, I will remove it outside. But first I have to simplify this integration minus infinity to infinity e raised to a square x minus I s upon 2 a square square. This will become, okay, I will take it separately, minus a square s square 4 a raised to 4 dx. So law of indices, I think you know. I can take out the separate powers of e. So now in this you can see this is a constant term, so I will take it outside. So this will become, this is equal to integration minus infinity to infinity. Okay, I have to take this common, that is what is constant, that is e raised to minus a square. Okay, I can again simplify here. What I can simplify, students? A square. See, a square one the, I can take this a square. A raised to 4 will become, this is a raised to 2. Okay, so minus s square upon 4a square, because one a square is cancelled, only remaining a square. Next, continue. Integration minus infinity to infinity e raised to minus a square x minus I s upon 2a square the whole square dx. Now you can see, yes students, I have, you can compare this equation. Yes, we know that this equation, you can see, it is exactly the same. Only thing, I have to substitute the values. There is paste, control V. You can see this formula, we have brought it in this form, right? Now we can see what I have to substitute here, students. It should look like t. So I will put, what I will put, a x minus is upon 2 a square. I will put just t value, so that you can see, if we further simplify, this will become ax minus is upon 2 a square is equal to t. Or if you differentiate this, okay, it will become a dx is equal to, this is constant term, please remember, this will become 0. This is equal to dt, or I can take dx is equal to dt upon a. So these two values I will substitute. One is this value I will substitute, another one dx value I will substitute. So that you can see this is equal to e raised to minus s square upon 4a square, integration minus infinity to infinity e raised to minus t square. You can see this is a square x minus I s upon 2a square the whole square. So this is t square. Is it clear? So now I can see this is t. Okay. Now dx. What dx is? Dx I will substitute dt upon a. So this is dt upon a. Now as you can see, I have exactly made look like this only. So this is equal to, I can see a is constant. I will take it outside. So here you can see, students, e raised to minus s square upon 4 a square upon a. So you can see integration minus infinity to infinity e raised to minus t square dt is nothing but root pi. Is it clear? So you can see it is of this form. So therefore I have substituted root pi. So this is our Fourier transformation. So this is how we have transformed, dear students. Okay. So now what we have to show, deduce that e raised to minus x square upon 2 is self reciprocal. I have to show. Yes, still we have not finished. Please remember this. So to show that this is reciprocal, what I do, I'll just modify this. I will just put a square is equal to 1 upon 2, or a is equal to, I can take this as square root 2, 1 upon square root 2. I will substitute these two values, I will substitute. So now I can see f of s is equal to, so wherever a square is there, it will be 1 upon 2. So this is minus s square upon 4, 1 upon 2. A will become 1 upon 2 divided by a square will become 1 upon 2. Sorry, a square will become 1 upon 2. A will become 1 upon square root 2 into square root pi. So this you can simplify. Yes, 2 1 the 2, 2 the this will become. So this will be e raised to minus s square upon 2. Yes, students, again this root 2 I will bring out, and I will put it in the numerical numerator. So this root 2 and root pi I can write it root 2 pi. Is it clear? So but remember this again. Yes, you can see here, students, why it's not getting down. Okay, so f of s is equal to, but please remember, what is 1 upon 2? 1 upon 2 is nothing but a square. We have already substituted the value. 1 upon 2 is nothing but a square. So again I will simplify. So this will become e raised to minus a square s square 2 pi. Can you see? Is it a reciprocal or no? Okay. So what I will do, here you can see this both the equations. I will just change the variable. Why this is getting down, I don't know. At the end part, say, sorry for that. It is getting close, I don't know. Okay. For, array, So this I can just change the variable x as x. So that implies you can see f of this is yes, this capital S is different. This is small s. So this is equal to e raised to minus x square upon 2 root 2 pi. Or you can see this also I will change f of s is equal to this is e raised to minus a square x square 2 pi. Students, by using these two equations, you can compare this equation and see root 2 pi is same, f of s is same. Only e raised to minus x square upon 2. E raised to minus x square upon 2 is nothing but e raised to minus a square x square. Means this is exactly the mirror image or it is self reciprocal. So therefore, we have deduced this complex Fourier transformation as self reciprocal. Therefore, comparing these two equation, we can say that therefore e raised to minus a square x square is self reciprocal. Is it clear, students? So like this, you have to simplify this example. Is it clear, students? If you have any doubt, please ask me. Yes, students. If you have any doubt, please ask me, students.